Hello dear student, myself Mr. Ashish Uddhav Shende, Assistant Professor, Department of Physics, Rashtrapita Mahatma Gandhi, Arts, Commerce and Science College, Savli. Today I am going to explain the second module of this online bridge course in physics, and that first topic is electric field. Okay, before the discussion of electric field, we first introduce about that the electrostatics. What is the electrostatics? Electrostatics is the branch of electromagnetics, and it deals with the effect of electric charges which is at rest or stationary position. In the electrostatics, that study of electrostatics is based on the fundamental law, that name is Coulomb's law. You know that the Coulomb's law. So Coulomb's law is simply study here. If these positive charges is a source charge and this negative charge is considered as a test charge. Okay, when the positive charge that considered as a source charge is produces the electric field in space. Okay, this electric lines of field is attract to this test charge which is negative charge. Okay, if there is a positive charge, then there is a possibility of repulsion. So if positive charge is exert a force on negative charge, okay, for the attraction, okay, and this force of attraction or repulsion between the source charge and test charge, that force is directly proportional, that force is directly proportional to magnitude of the charges, and it inversely proportional to the square of the distance between them. This is a simple statement of Coulomb's law. Okay, now what is the statement of this Coulomb's law? Coulomb's law state that the magnitude of the electrostatic force, the magnitude of the electrostatic force of attraction means was positive and negative charge, and repulsion when there is a similarity of positive or negative charges. Okay, so negative charge is not a source charge, is only the test charge, and the positive charge is always a source charge. So therefore, if there is a attraction or repulsion, that depend on the similar uh, charges or different charges. So that what is the statement of Coulomb's law? Coulomb's law state that the magnitude of the electrostatic force is directly proportional to stationary point charges. That means uh, magnitude of that stationary point charges, and it inversely proportional to the square of the distance between them. Okay, so this is the simple statement of Coulomb's law. So look this picture. If I consider here two charges Q1 and Q2. Okay, so electrostatic force F is directly proportional to Q1, Q2 and inversely proportional to d square. So by solving this equation, we get, so proportionality constant it replaced by 1 by 4 pi epsilon naught into epsilon r, okay, into Q 1 into q2 by d square. Okay, these equation when we solve, we get f is equal to 1 by 4 pi epsilon into q1 by q2 d square, or it is also written as f is equal to k into q1 into q2 by d square. Okay, that k is what? Proportionality constant. Okay, so the value of this k, the value of this k, it is depend, okay, on a medium. That medium are vacuum, air, so this is a Coulomb's law. And now one thing is remember is here, the direction of the forces is always along a straight line joining 2 point charges. Okay, that Coulomb's law, quantities here, that Ke, that is Coulomb constant, which is value is 9.0, that means 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Then q1, that is the electric charge, q2, that is also the electric charge, one is test charge and another one is source charge, and this is r. What is that? Is the distance between them. And this formula is shows that the electrostatic force is directly proportional to the magnitude of the charges, that point charges, and inversely proportional to the square of the distance between them. Okay, and hence due to that electrostatic force in the space or region surrounding a source charge, in which the test charge experience a electrostatic force, that force either attraction or repulsion, and that region or that field is known as a electric field of source charge, and hence we consider that field is called as a electric field. So what is the electric field? Electric field, the space or region surrounding an electric charge which is source charge, so q is a source charge, okay, in which another test charge q experience the electrostatic force. सो Q जो है वो क्या एक्सपीरियंस कर रहा है? इलेक्ट्रोस्टैटिक फोर्स एक्सपीरियंस कर रहा है. ये फोर्स दो तरीके का हो सकता है, या तो ये अट्रैक्शन होगा या फिर ये रिपल्शन होगा. अट्रैक्शन कब रहेगा? जब पॉजिटिव और नेगेटिव चार्ज रहेंगे, और रिपल्शन कब रहेगा? जब दोनों चार्ज या तो पॉजिटिव पॉजिटिव या फिर नेगेटिव नेगेटिव रहेंगे. तो इलेक्ट्रिक फील्ड की सिंपल डेफिनेशन हम क्या कंसिडर कर सकते हैं? यहाँ पर ये पॉजिटिव क्यू, यानी कि क्यू चाहिए था. सो द स्पेस और रीजन सराउंडिंग एन इलेक्ट्रिक चार्ज क्यू in which another test charge, that small q, that is the test charge, experiences a electrostatic force of attraction or repulsion, such a field is called as a electric field of the source charge. किसकी फील्ड रहेगी? वो सोर्स चार्ज की. ओके, and this field is called as a electric field. Now so look here, this source charge create such a field because of electrostatic force. Okay, and this force is tested by this small point charge. That means this charge is tested this field of force of attraction in this region is attractive or repulsive. Okay, so such a field is called as what? Electric field, which field around the charge which is by produces by test charge. That region or that space is called as a electric field, and this line of force is called as a electric field of lines. Now the another term is electric field intensity. Okay, we know about that the electrostatic force as well as electric field. Okay, electrostatic force, that force of attraction or repulsion between two charges which is separated by some distance. And electric field is what? A such a field which is created by a source charge surrounding them and which test by the test charge. Okay, that field is known as electric field. Now what is the electric field intensity? Electric field intensity is defined as the electric field intensity at a point due to the source charge is defined as the electrostatic force experienced by a unit positive charge that at that point. Okay, what is the electric field intensity? Electric field intensity is defined as electrostatic force experienced by unit positive test charge placed at that point. Okay, so unit positive test charge, there is missing this word, so for that, sorry. So now if F is the electrostatic force, Q be the point charge, and according to definition that electric field intensity is nothing but the force per unit charge, that point charge. Okay, and hence force is what? Force is equal to K into Q by d square. Okay, if divided by again Q, then this Q and this Q, that means one, this and this will get cancelled, so remaining is here electric field is equal to K, that is constant, proportionality constant, then Q, that is source charge, and D, that is the square of the distance between two charges, source charge and test charge. Okay, so electric field intensity is defined as E is equal to K, that is proportionality constant, into source charge divided by the square of the distance between them. Okay, so now what is the unit of electric field intensity? And electric field intensity is a vector quantity. Okay, so electric field intensity is having unit is newtons per coulombs, or it is measured in also volts per meter. Okay, now what is the dimension? The dimension of this electric field intensity is m 1 L1 T minus 3 A minus 1. That means m means what? Mass, L means what? Length, T means what? Time, A means what? Ampere. Okay, so this is the dimension of electric field intensity. that dimension of electric field intensity are m1, l1, t minus 3, a minus 1. Now the another term is that electric potential. Okay, this is also simple term, that electric potential at a point in a electric field is defined as the amount of work done in moving a unit positive test charge from infinity to at that point against the electrostatic force. What is the electric potential? So I will explain in this slide. Suppose this point, the positive charge. Okay, consider an isolated point charge plus q and lying at a point O, okay, in this line. Okay, and hence consider an isolated point charge positive q at point O, due to which there is an electric field around it. Okay, इसके अराउंड में इलेक्ट्रिक फील्ड भी है. इफ़ वी मूव द पॉजिटिव टेस्ट चार्ज, दैट मीन हम यहाँ पर एक टेस्ट चार्ज कंसिडर करेंगे पॉजिटिव फ्रॉम इन्फिनिटी to a point, suppose that point there is a B, okay, to a point B in electric field, then it have to do work against the force of repulsion. okay, ये क्या करेगा, इसके अगेंस्ट वर्क करेगा. दैट मीन्स it will have to do work against the force of repulsion, and hence let W, that is the work done in bringing a test charge q naught from infinity to a point B, then the electric potential V is equal to work done by point charge. ओके, तो सिंपली आप कह सकते हैं कि इलेक्ट्रिक पोटेंशियल एक ऐसी चीज़ है जो टेस्ट चार्ज को फ्रॉम इन्फिनिटी टू सम सच एट दैट पॉइंट विच इज एक्सपीरियंस इलेक्ट्रोस्टैटिक फोर्स. ये इन्फाइनाइट डिस्टेंस से एक ऐसे पॉइंट तक लाने के लिए जो भी फोर्स रहेगा, वर्क डन लगेगा, कि जहाँ पर इलेक्ट्रिक फील्ड एक्सपीरियंस की जाए या फिर इलेक्ट्रोस्टैटिक फोर्स एक्सपीरियंस किया जाए, तो उस वर्क डन को आप कंसिडर करेंगे इलेक्ट्रिक पोटेंशियल में. ओके, सो हेंस इट डिफाइंड एज द इलेक्ट्रिक पोटेंशियल एट अ पॉइंट in a electric field is defined as the amount of work done in moving a unit positive test charge. तो ये भी पॉजिटिव है, ये भी पॉजिटिव है, तो इसमें क्या हो जाएगा, ये भी पॉजिटिव, ये भी पॉजिटिव, तो इसमें क्या होगा, फोर्स ऑफ रिपल्शन होगा. क्या होगा, फोर्स ऑफ रिपल्शन होगा. एंड हेंस द वर्क डन, किस लिए वर्क डन यूज हो रहा है, वर्क डन इन मूविंग अ यूनिट पॉजिटिव टेस्ट चार्ज फ्रॉम इन्फिनिटी टू दैट पॉइंट, फ्रॉम इन्फिनिटी टू दैट पॉइंट बी. ओके, अगेंस्ट द इलेक्ट्रोस्टैटिक फोर्स. बट यहाँ पे दोनों भी पॉजिटिव होने के कारण ये क्या हो गया, फोर्स ऑफ रिपल्शन हो गया. एंड हेंस अगेंस्ट द इलेक्ट्रोस्टैटिक फोर्स दिस क्वांटिटी इज कॉल्ड एज इलेक्ट्रिक पोटेंशियल. दिस क्वांटिटी इज कॉल्ड एज इलेक्ट्रिक पोटेंशियल. सो इलेक्ट्रिक पोटेंशियल इज इक्वल टू वर्क डन फ्रॉम इन्फिनिटी टू पॉइंट बी डिवाइडेड बाय, किसके वजह से हो रहा है, पॉइंट चार्ज क्यू नॉट की वजह से. ओके, सो हेंस इलेक्ट्रिक पोटेंशियल वर्क डन बाय पॉइंट चार्ज. तो फाइनली इसका जो यूनिट होगा वो होगा वोल्ट या फिर जूल पर कूलम। ओके, एंड हेंस 1 वोल्ट की वैल्यू होगी 1 जूल per 1 coulomb. Okay, so that the potential at a point is said to be 1 volt if the work done of 1 joule and the moving positive charge of 1 coulomb from infinity to that point. Okay, and the dimension of this electric potential are m L2 T3 a minus 1. Okay, thank you.